In this video, we'll take a look at multiplying radicals and recognizing that we may be able to simplify after multiplication. To do so, we try to identify any perfect square factors of the radicand. So using the product rule, we would multiply these two radicals together, which states multiply the radicands together. Rather than putting 112, which is the result of 2 times 56, I'm going to write the prime factorization. Here's 2. 56 in prime factorization would be 2 times 28. 28 is 2 times 14. 14 is 2 times 7. Note that 2 times 2 is 4, which is a perfect square, and likewise we have it again. So we have, in this first two factors, the equivalent of square root of 2 to the second power. Likewise with this next pair of 2's, 2 to the second power, square root of it, and our square root of 7. Simplifying, we'll have a 2 and a 2 with our square root of 7. Multiplying, to simplify further, we have 4 times the square root of 7 for our final simplification of this problem. In the next problem, similar, instead of taking and multiplying 14 times 7, let's do the prime factorization of this product of these two radicals, which is the product of the radicands underneath one radical sign. So in place of 14, prime factorization is 2 times 7. Rearranging while I'm at it, I'll put the other 7 followed by the 2 A's. Recognizing again here, we have a pair of 7's, and just to show the steps, 7 times 7 can be written as 7 to the second power underneath a radical. Likewise, we have a times a, which can be expressed as a to the second power. And we can't forget that we also have a 2 as one of our factors underneath the radical sign. Simplifying, square root of 7 quantity squared is 7. Likewise, square root of a squared is a, and our square root of 2. This is simplified since there's only one factor of 2 and it is not a perfect square. At some point, you may be able to skip directly once you see that you have a pair or a factor and it's self-multiplied together directly to the final answer here. One more example of multiplying and simplifying. We can do our prime factorization in the last, as we've done in the last problem, or recognize 24 is 6 times 4, and our 6 with the 6, we have a pair of 6's. So let's use that as an alternative solution or procedure. So putting our integers together, we're multiplying the two radicals together. The multiplication of radicals is to multiply the radicands. So 6 from the first radical times, in place of 24, a 6 times 4. Multiplying the like terms together, we have common base of a, which says add the exponents together. So 3 plus 5 will give us a to the 8th, and common bases of b, we have b to the second and b to the first. I'm going to leave those separate because of the fact we would have an odd power. So simplifying here, we have a pair of 6's. Square root of 6 squared is 6. Moving on to 4, square root of 4 is 2. Square root of a to the 8th, we'll divide that exponent by 2, or take half of it, which is a to the 4th, since a to the 4th squared is a to the 8th. Square root of b to the second is b, and b to the first is not a perfect square, and we'll leave it as that. Simplifying further, we can multiply our integers. We end up with a 12 a to the fourth b times the square root of b for our simplified product of these two radicals.